In this video, we are going to see how to run standard linear regression. So I started the script by cleaning the memory and the console to have a clear workspace. And I'm going to load the data as usual. So from the file gasolineu.dta. And we see the data is loaded here in the data frame my data. So for the standard linear regression model, I'm going to use the command lm for linear model, and I have to specify what model I'm going to use. So I'm interested in the relation between the quantity and the price, controlling for the wage and the population in each province. So I want the quantity, and I want to regress that on price, the median wage, and the population. The data comes from my data, so I put this with data equal my data. And I want to save the output of the regression in the variable linreg, or let's call it linreg1. So I run the command and I see that the values have been saved in linreg1. It's not very readable right now, but I can have a summary for it. So I'm going to ask for a summary of linreg1. And here I see the output. So I have some data about the residuals from the regression. And I also have the estimated coefficient. So the intercept is about 1,400. And I have the effect of the price, the effect of the wage, and the effect of the population. Important here, we have the p-values, so we can see that the intercept is very significant. However, the price and the wage and the population are not that significant. The price seems not significant at all. The wage is significant at the 10% level because 0.07 is smaller than 0.10. And the population is not even significant at the 10% level. So our model seems not that good. If we look at the F statistic for the full model here, we see that the p-value is about, is very small, 3 times 10 to the power of minus 7. So the model is significant overall. So maybe with the output of this regression, I want to do some more manipulation. I can get the fitted values, the quantities hat, or sometimes we call them y hat. So for that, I use the command predict. And I want to predict using the linear regression 1, so linreg1. If I run the command, I see I have all the y hats in the output. Maybe I want to use the residual. So I use the command resid, and in that case, in the output, I have all the residuals for each observation. Maybe I want to compute the total sum of square. So for that, I'm just going to write completely the equation. So the sum of square total is the sum of the quantity minus the mean quantity, and we square it. Each quantity minus the mean is squared, and then we add them. And I get total sum of square, I see here, of 2 million something. I can do the same with the sum of square explained by the model. So I call it SSExp. Sometimes it's called SS regression. Instead of using the quantity, I use the predicted quantity, so the quantity hat, and minus the mean quantity squared. We square the difference. I run the command and I get the SSE here. And finally, I'm going to get the sum square residuals. So it's the same command, but instead of using predict, I'm going to use resid for the residual. And I get the value for the SSR. So we know that the R square should be equal to SS explained over SS total oh, I didn't call it SS total, I called it SST. And I see the R square is 0.2666, and this is what I found in the regression normally. Yes, here we see that the R squared is 0.2666. So about 26% of the variation in quantities can be explained by this model. If I want to test for more coefficient than just one, so I had the p-values for price effect, wage effect, and population effect, maybe I want to jointly test two of these variables. So in that case, I'm going to use to run another linear regression. I'm going to call it linreg2, and I'm going to just copy the first comment, but remove wage and population. So we are going to regress only quantity on price. And then I'm going to compare how well these models do. So the command is ANOVA, then the output of the first regression, the output of the second regression, and I see here is the two models, so quantity on price, wage, and population, and the model 2 is quantity just on price. And I see that the p-value here is 0.12, so the wage and population are not significant at the 10% level. They will be at 15, but I've never seen 15 used as a significant level. Usually it's 5 or even better 1, so this is quite large. Finally, I'm going to show you how to do a regression on the subset of the data. So I'm going to use a shortcut here. I'm going directly to call the command summary. And I want a summary of the output of the linear regression of, let's say, quantity over price. And here's the data will be my data, but I'm going to use a subset of my data. So I'm going to open the square brackets here. And within the square brackets, I'm going to say I want only observation where my data year is equal to, for instance, 2001. So I'm going to run the regression on the 2001 data only. And then comma, and I leave the second space empty to say I want to use all the variables for my data. Oh, I need to use a double equal here to say that, again, I want the year to be compared to 2001. I don't want the year to be set to 2001 for every observation. And here I run the regression, and I have the output, intercept, and price interpreted as before. And we should see that we only have so for 2001, I have 10 provinces, so I should have only 10 observations for this regression. In the next video, we are going to cover regressions with dummy variables and trends.